Okay, so today's topic, we're talking about cooling pads and acute heat stress in lactating sows. So heat stress is what happens when animals get too hot. So there's a thing called the thermal neutral zone, and humans often we call it the comfort zone. And there's a lower critical temperature and an upper critical temperature. And these are temperatures where if the animal gets below or above this, they start to exert extra energy trying to keep themselves cool or warmer, depending on which critical temperature you surpass. The thermal neutral zone can be affected by humidity, as well as the surface area exposed to surrounding air. A lactating sow, the thermal neutral zone is about usually between 60 and 70 degrees Fahrenheit. And here it just shows a graph of the correlation between humidity and temperature in a sow. You can see down here at the bottom there's no heat stress, and then as you increase in temperature as well as go to the right across humidity, as you go there's different levels of danger. And then once they get so hot it can become fatal. So some problems that come with this. For every there was a kind of a rule kind of thing that I found that for every 1 degree Fahrenheit above the thermal neutral zone, a sow will eat approximately about 0.2 pounds of feed less a day. So that is large impact on the animals, but also such as in lactating sows, the piglets are also then getting less nutrients and stuff like this. It's projected in, I think it was 2015, that the U.S. was actually losing about $360 million from the swine operations because of just the side effects of heat stress on the animals. Pigs don't really have sweat glands. They only have them in their nose, and it's not really for to control temperature, more of just to keep their noses and their muzzle area damp and wet. So pigs often use wallowing as a way to get cooler. They'll go find a nice mud hole or a spring and roll around in it, and then the water evaporating off of them is what cools them. Another problem that comes about is, as we saw in the last slide, the sow's thermal neutral zone is approximately 67 degrees Fahrenheit. However, her piglets, their thermal neutral zone is 84 to 90 degrees Fahrenheit the first few days, and then as they get larger, it starts to decline. Their thermal neutral zone starts to lower as well. Purdue recently did a project on some cooling pads, and the concept of this is trying to reduce the body temperature of the sows while allowing the piglets to stay at the higher temperatures. So the pads take away heat from the body through conduction and convection. This right here is as a pad, kind of just illustrating the part of the pad itself. Water will flow through the pipes and gain heat from there's a metal plate that goes over this, so they gain heat from the metal plate, and then they use well water, so it's just groundwater, which is usually 52 degrees Fahrenheit. And so then as they go through the copper loops, the water increases the temperature and takes the sow's heat and transfers it, and then it leaves to a different area.
Where is that water dumped? Is it dumped someplace? Or?
There's several different operations. If they're larger operations, they were thinking that they could do something similar to a geothermal.
Okay.
However, if it was when we were running the tests, we only had 12 pads to begin with and 24 later on, and so they were just going into the pits, the middle
Okay.
pits, in this case. And so then the heat is through convection. The sows laying on top of it goes to the onto the metal plate, and then the metal plate then transfers it into the water. So here's a little bit more of the details about the experiment at Purdue. So they heated a room up to 96 degrees Fahrenheit and approximately 60% humidity. And they took respirations rates and rectal temperatures to just kind of measure how comfortable the sows were. So at the temperatures of 96 Fahrenheit and 60% humidity, the sows that were not, where the pads were not being used, they had 132 breaths per minute and were about 40 degrees Celsius rectal temperatures. With only 0.25 liters per minute going through the pads, it lowered it to 89 breaths a minute and about 39.5 degrees Celsius. 0.5 liters per minute reduced the respiration rates to about 71 and 39.2 degrees Celsius. And then the high, which was 0.75 liters per minute, was about 31 respiration rate at 39.1 degrees Celsius.
So those are pretty dramatic effects.
The 31 breaths per minute and 39.1 degrees Celsius was actually lower than the temperatures that was at about 65 degrees Fahrenheit and also 60% humidity. So we had the high flushing rate at 0.75 liters per minute was almost too high. We had some sows that got so cold that they actually stood up to get off the pads.
Okay. I was going to ask you, because the one in the picture is laying, lateral recumbency, and I was going to ask you, they stand up sometimes, but that's interesting. The high one was almost too cool.
Too cool with such the temperature change that a lot of them would actually get up and flip sides.
Oh, yeah. Now the well water, did you verify that it's coming in at what did you say, 52?
That's just the temperature I found online. The ones that we were using, we had insulated, the pipes we had weren't quite insulated, so they were entering about, it was 56 or 58, depending on the day.
Mm-hmm.
So they weren't quite as...
but still dramatically less than her skin temperature.
So
there's your resources. So is it cost effective? Because you can have something that really does a great job, but it could cost you much money. Did you guys do any?
It kind of depends on how large of operations they have. The more pigs, the more pigs you have, you're already going to have the system in place. So the more pigs, the less cost per pig and per mat. And then it also would depend on if you went like a geothermal. So then all you're really paying for is the electricity to pump it up out of the ground and then have it drain back down.
Go back into the ground.
Yeah. And then if you were to use like a cooling system or something like that, then you're also going to increase your cost quite a bit because you're paying for the electricity to cool